Dougie Doo notes that if the expansion of the universe is increasing the wavelength of light, that means that the light's energy is decreasing. Given that physicists say that energy is conserved, where does the energy go? Hi, Dougie Doo. So the answer might surprise you. Conservation of energy isn't absolute. Now, me saying that conservation of energy isn't really true is pretty staggering and requires some explanation. Bear with me because this is somewhat technical. The story begins with a theorem created by Emmy Noether called Noether's theorem. This theorem connects conservation laws with mathematical properties of the theories that describe them. According to the theory, a conserved quantity implies that the equations don't care where you set your zero. For instance, for conservation of energy, the equations don't care what moment you set as time zero. It could be just over 2,000 years ago, it could be the moment you were born, or it could be this very second. If the laws of physics don't care about that choice, energy will be conserved. But an additional requirement is that's never mentioned is that space and time must be static and unchanging. But of course, in general relativity, that last requirement is not satisfied. Space and time can change and warp and distort. Accordingly, the law of conservation of energy doesn't necessarily apply. So that's the reason that it appears that energy is lost. It's because the non-conservation is not only allowed, it's expected. Now, the description I've given here is the gist, but because of the limited time we have, it's very brief. So I've put links to 2 more thorough and technical explanations in the video description below. If you want to understand this better, you're going to have to read those.